Hi everyone. Welcome to video 8. This is our introduction to rational functions. We've basically stopped talking about, or we finished with polynomials, and we're ready to move on to our next class of functions. Also, at the very end of this video, I'm going to do a little bit of quick algebra review as it actually relates to rational functions. Let's get started. So first off, what is a rational function? There's a pretty simple answer to that question. It is just a fraction that has polynomials in both the numerator and denominator. So you can read it as polynomial over polynomial. And I have a bunch of examples here to illustrate that. The first two examples are pretty straightforward. It's a fraction. Up top is a polynomial. Down below is a polynomial. Same with the second one. The third and fourth ones are also technically correct. Even if I have a constant term like this 4, that's still technically a polynomial. So putting 4 over x squared plus 7 is also a rational function. And the last one is, well, that's actually just a polynomial. X squared plus 5x plus 3. So because I can put that over 1 and not change anything, that technically means that every polynomial is also a rational function. So you can picture that we have all polynomials and a slightly larger Venn diagram showing all rational functions, meaning that this is a larger class of functions that includes polynomials. Okay. So let's talk about solving rational equations. So since we spent so much time talking about solving polynomial equations and how you find the roots and things like that, you might think that we have to start all over again with solving rational equations. But the simple answer is we don't, because we can turn any equation of rational functions into a polynomial equation and then just solve that the way we solve any other polynomial. So the only tool, really the important tool for doing that is just regular old cross multiplication, the same way that you set up any equation between fractions. So I have an example of that here, where I have a rational function equal to another rational function, and it's just an equality between two fractions. So if I do the regular cross multiplication, I get x squared plus 4 times 3 equals x minus 3 times x plus 2. Remember, with cross multiplication, there's a lot of different orders that you can do it in that will give you the same final result. So then in order to solve that, I have to simplify everything and get everything over to the same side. So first off, I kind of distribute and FOIL out both sides. And then I move everything on the right to the left by subtracting and adding, as the case may be. And when I did that, I got 2x squared plus x plus 18. After the first step, basically, we're in regular polynomial land. And in this particular case, it's a quadratic. So we can use, for example, the quadratic formula to solve it. I did that. And in this particular example, I got complex roots. Which is an answer. I mean, if I was looking for complex solutions, that would be my answer. But if I was looking for real solutions, I would have to say that there aren't any real solutions. So the important thing here is that we can turn every rational function into a polynomial equation just by cross-multiplying. Okay, so rational functions can also be simplified because, again, they're a type of fraction. And how do we simplify fractions? Well, we find the common factors in both the top and bottom. But in this case, where we have polynomials, we have to be able to factor those polynomials to find the common factors. And that can be challenging because factoring is not always easy. But here in this particular example, I just have quadratic over quadratic. So I can use any of my quadratic tricks to factor both the top and the bottom. I did that here. And I do want to point out that in this numerator, it was helpful that I pulled out this 2. Because if I had written it just as x times 2x plus 8, for example, I might not have seen what I was looking for. Because after I pull out the 2, what I notice is that there's an x plus 4 as a factor in both the top and the bottom. And that's what lets us cancel. We're basically dividing both sides by the x plus 4. And then the simplified form is 2x over x plus 2. They no longer share any common factors, so that rational function has been simplified. Okay, so I have to talk a little bit about simplifying functions. And this is an issue that actually came up with some of our domain problems earlier in the class. Is a simplified function equal to the original function? I mean, we write equals, so that would seem to suggest yes, but the answer is actually more complicated. The answer is not quite, and that is because when you simplify a rational function, you're basically removing holes in the domain that might have been there originally. And I'm going to use this example to explain the difference. They actually are slightly different functions, and they're even going to have different graphs. So in this example, I'm going to start by graphing the simplified form, which is the y equals 2x. So it's good to just check that I could take the thing on the left here and simplify it to the thing on the right. Okay, so if I graph the thing on the left, that's pretty easy. That's just y equals 2x. Okay. Now, if I graph the function on the right, it's almost going to be the same thing. But the difference is that the function on the left has a problem with the domain. The problem is that I can't plug x equals 0 because I cannot divide by 0. Even though I will have 0 over 0, that still is not okay. 0 divided by 0 is still undefined. So the difference when I graph this one is that it's going to be the same, but with a hole at x equals 0. Okay. So that's the difference. They're almost identical, except that this function, the original function, has a hole, and that by simplifying it, that hole has been removed. And that can actually be a good thing, because we might want to know what was originally in that hole. If I were to just plug in x equals 0, or I wanted to plug in x equals 0, and see what would be in this hole, that would be difficult without canceling. So there are good reasons that we might want to remove the holes in the domain, but it's good to know that that is actually happening and that they're not quite the same. And there's a warning here, because if you were to just plug either of these things into your calculator or Desmos, you would get the same, and that's because your calculator does not know about holes. It's actually just plugging in a bunch of numbers randomly, so it has no way of telling that there was a hole there to begin with. Okay, so for this last part of the video, this is going to be a little bit more review, but I want to go over some very common algebra mistakes that occur particularly with rational functions, but this is kind of even more general than that, I think. And these are things that I've seen before on some of the early quizzes, so I just wanted to address these specifically. What you see here are 3 different problems, or 3 different questions, and for each of them there is a mistake. The answer that is written is not correct. And what I think it would be great to do is to actually pause the video, see if you can identify what went wrong, and maybe even correct it. Maybe even find the correct way to simplify each of these. And just note that the answer might be that there is no simplification. Okay, so I'll let you do that now. I'll let you pause it now, and then I'll explain, then I'll give the full explanation. Okay, so the issue with the first one is that, well, maybe if we want to cancel something from a fraction, we have to be able to cancel it from all of the terms. So I cannot cancel 3x from this unless that 3x appears in every single term, and because it doesn't appear in the x squared, this doesn't work. So this is not correct. And what I would do instead is, starting from the beginning, I could factor both the top and the bottom. If I factor the top, I get x times x plus 3 over 3x. And now I see that, in fact, I can cancel an x because I have an x up top and an x down below. So if I cancel that, I will get x plus 3 over 3. Okay, and that would be correct. All right, so the second one is wrong. If I'm adding 2 to both top and the bottom, I can't just subtract something from both sides of a fraction. It's not like an equal sign in that way. I can multiply something to both top and bottom. I can divide something from both the top and the bottom, but I cannot add or subtract. So how do I fix this? Well, truth be told, I can't. There's nothing that I can factor out here. And in this particular example, the top does not factor over the real numbers. The bottom does, but in a very, very complicated way. And the simple answer to this is that it doesn't simplify at all. So this is not correct. And there's really no simplification I can do. Or maybe what I would say is that it's already simplified. Okay, so for the last one, a little bit like the first one. So the attempt was to cancel the 2 from both the top and the bottom. But just like with the first problem, if I'm going to divide both sides by 2, I have to divide all of the terms by 2, and that includes the 3. Okay, so the problem here is that we have not divided the 3 by 2. Now, this is easily fixable because it's not right. But what I can do is I'm going to start from the beginning. I can divide everything by 2 and get x to the 4th plus 3 divided by 2 over 1. And now that's the same, dividing by 1 does nothing. So that's the same thing as x to the 4th plus 3 halves. So that's not the only form I could have written that in. And there's an argument to be made that even in the original form, it's fine. But just want you to let you know that if you're going to take a 2, you would have to take a 2 out from everything. So these are just a few common mistakes. And I get it. I think that when I point this stuff out to you, in every single case, people have been like, oh, I realize what I did wrong. I know this is probably what happens when you make this mistake is you're just going too quickly or you're a little bit anxious. So I know that's the case, but these are just important things to watch out for in the future. Anyways, I hope you have a great day, and I will see you in class.